I will start the the last part of this whole series. So this is the last 15 minutes. Um, all of you must be tired, but it's just a little bit more. So just bear with me for another 4 kernels, and you will have a proper FMM code working. And yeah, so we've done P2M and M2M, so I'm just going to go to M2L. M2L is a bit more complicated. It's longer because, so remember, we have the derivative of G in this kernel, and it's sort of written in this code, but it gets very long when you write it like this. So, okay, so I'm going to gradually move to this, and so the dx and the dy will be calculated. So I can erase the original kernel because I'm no longer using it. Those things, and so I'm just going to code according to the thing I'm seeing on the left. Seeing on the right, and copy it to the left. So M Oh, there's something I haven't defined. Inverse of Z. How is that defined? Oh yeah, I'm actually defining many things here. Okay, let me make sure that I copy these 2 things too. Okay. So I have this thing, and also the inverse is defined as this operation here, or do I have another thing? Where is POW ZN defined? Here, okay. So I have many things here. No. So it's just that this thing is defined like this. Okay. So it's a little bit different from the M2M in the sense that I have to define all these complex numbers before I start the calculation. But then these are being used in like a recurrence relation, and then that's why I need POW-Z, which is probably going to be used in a recurrence relation for n only, and the POW-Z nk is going to be used inside the double loop of the recurrence relation for both indices k and n. Okay, so again, I'm going to define, so I'm going to have a loop for k and n. K starts from 2 in this case. K. So I'm just copying basically the code. I'm just looking at the code on the right and copying, and I'm doing this manually because I think it's faster than doing copy and paste to do it this way. Because of the small differences, basically. So if I copy and paste, I'll need to do the correction anyway, and I think typing in will give me less bugs. Okay. So if anyone sees me typing something wrong, then please let me know, because I may make a mistakes at some point. So what is this? Yeah, I think for this part, copying is faster. Okay, so I'm done up to here. I think this is almost, yeah, so this is end. Okay, so now I have the M2L kernel. It was like, what, about 30 lines of code. It's still 30 lines of code. It's not like excessively long or anything. It's, okay. I just need to make sure everything is correct. It's always good to double check after you copied something, because copying is the source of bugs. Okay. So I'm going to try to compile, because the M2L is the most complicated part of the code. I'm getting some strange numbers, and I don't know why. So this is, now I have to start debugging. So it could be because the M is already wrong in the previous calculations, and when I do M2L, it actually substitutes numbers into the L0, so it actually changes the results. So, well, so there's something wrong with either the numbers that are being input here, so maybe I can just go back to P2M and start printing stuff, because the error could have happened starting from P2M, because we've been changing the values here. So first, let's just confirm that the Z is correct. So C real will print the real part, and C imaginary will print the imaginary part of Z. So if I do this, or maybe if I write like this, it would be more familiar. Okay. And then, okay, so this doesn't look that strange. It's just outputting all the X and Y values. Yeah. This looks okay. Because it's the distance from the center to the points, it shouldn't be that large because they're both 2 points inside the same small box. Okay, so it shouldn't be like, you know, close to 1 or anything. So these numbers look okay, and it's the proper complex number. Okay, so now let's try to look at the higher order terms of n. So before we do that, let's see if Pao Z is being calculated correctly. Okay, and then we can output the n here, so okay. So because P is 3 right now, it's only going to loop over 1 and 2. And the numbers look okay to me. Now let's print these values here. Okay, so there's no strange numbers here. So it seems like something strange happens here. Now the first thing to check is always, you know, to check if Z is again correct. Yeah, it looks okay. Okay, so here I'm seeing infinity. Okay, so I think this log function is not calculating the complex log. Yeah, in C++, I'm using C++ and other code, so it's okay there, but it seems there's something wrong with this number that's being calculated here. Um, Yeah, I think the fact that it's not returning any imaginary values means it's probably not calculating it as a complex. Ah, maybe I can use this thing. Oh, good. Now it works. Okay, so I just had to add this this extra header file, tgmath. I think it works in most compilers. It should. You can try include tgmath, and then the log turns into the proper type. The log, it turns into a complex log properly. Without this, the log tries to do like a not complex, like a real number log, and it fails. So now I should not be getting strange answers here. Except I probably won't be getting correct answers either, because one main thing is that, I first need to change the P2P kernel, because this complex number that I'm using is also not 1 over r. It's the proper 2D Green's function, so it's the log r function. Where's my P2P definition? Here, yeah. So this needs to be like a log. Okay. Now I should be getting matching answers, I think. No? Okay, well, maybe I'll just proceed and see if they match in the end. Okay, I'm going to move to L2L and see. Okay, so I need to define similar things to the M2M kernel. Okay, complex POW and loop Okay, now L2P is just one more, and then I can debug. So this is almost the same as the P2M. You just take the power, which is like the power of z and the factorial n, and just add this to u. So these are the high order terms coming from the high order local expansion, L, and just multiply them to pow z and they should be the correct, yeah. Okay, so this should be giving the correct numbers. Okay, now let's check if see if we can debug the answer. Okay, it's giving strange numbers again now, and we can see why. Yeah, hopefully we can debug this by the end, and then we'll have everything working. Okay. So if I don't have any high order terms, it should still give us the same answer. So we can debug this in different stages. We can, if I don't sum, okay, I shouldn't be summing starting from 0. That's one thing. Okay, okay. Okay, so there's now some difference that is probably coming from the difference in the definition, because this code is working like this on its own. So there must be some mismatch in the definition of things. So like the dx I changed here, and dx here I also changed cj minus ci. And here onwards it's okay because dx is always ci x minus cj x, also in the L2L kernel it's ci minus cj, and here it's b minus the c index. Okay, so one thing we can do is to first try to eliminate all high order term. There's an easier way to eliminate high order terms. I just set p to 1, and it should reduce to the original equation, except we're now using like the log function, so I need to check if that one is working, basically. Yeah, okay, so there's a problem even with just the first order. So this one is just calculating m0, and for this one it's just, also m0, and then this one is calculating basically this minus log z. And so the P2P should be calculating minus log. Is this okay? It's calculating log r. Yeah, this is a little bit concerning. Why don't I just calculate double complex z? And Okay, it's getting close. Okay, but there must be still some definition difference in my code. Yeah, but I guess the distance thing is no longer an issue because I'm in the first term, it doesn't appear in all the kernels except the M2L. And basically in this kernel, everything down here should be not functioning. So maybe I can just check. Okay. Why is this giving a different result from this? No, it's not. Oh, it is. There's some contribution from, what, M1 is not 0 somewhere? Okay, this is very strange. Okay. Yeah, it should be the same thing. Yeah. Hmm. Okay. This might be a little bit difficult to debug with this approach, so I'm going to go back to step 11. So I changed, I think, too many things at once. So one thing I need to check is if this works with the log kernel. This is something that this is a change that happened independent of any of that high order terms. Okay, so I'm already seeing some difference here. Ah. Okay, so if this doesn't match, then there's a fundamental problem to this approach. I don't really understand why this doesn't work, though. So I'm changing G from 1 over R to basically log 1 over R, which is log R minus log R. Ah, minus log R means I need to multiply by it. Okay, maybe that's a problem. Okay, it's good to have all these intermediate steps because, you know, that was some stupid mistake I was making. So yeah, here I am multiplying. Similar, but not quite. Okay, so, well, it's good that I have step 11 working. Step 11. And step 12 should be giving the same answer when I put p equals 1. So it's easy to debug based on this. Yeah, so What's the difference? So the direct calculation is giving the same result, it seems. Yeah, maybe I can split the screen so it's easier to see this. So, no, this doesn't work, I guess. Okay, we're almost there. I think it's just one more bug that we need to fix. Because step 11 should be giving the same answer. So step 11 gives step 12, no. Step 12. So the thing on the right side is the same, because of course it's the same, it's the direct part. And if I set p equals 1, so step 12.c, when I set here p equals 1, it should do the exact same calculation. And if it's not doing the exact same calculation, it's very easy to find where it's not, because this part should be identical. And if I do this here, because p is 1, so this should just calculate for 0 to 0, and this part should not even run. But just in case, well, let's not do this, because these parts should not be running. So this is obviously not the part that's the problem. And this part, I don't know what's happening down here, but I'm going to not calculate any of this so that I'm sure that none of that is harming the execution. And then here, this should be executed for only 0, and here, so just 0 being added on here. And also here, the real part being extracted. Maybe is that the problem? This should not be the real. Okay. Let's see what this is giving, because no, it's still. Is it almost the same? No, because this one gives much close. Okay, I need to compare side by side. So the one on the right is 11, and this one is 12. So now they're matching. Okay, so apparently something strange is happening inside this commented out thing here, and it's changing the result, because if I don't comment this thing here, then step 12 returns quite different results. Yeah, see this 160 and all these strange things. So why is that happening? Because here I'm not touching anything. This loop shouldn't even be running. Here I'm only adding to L1. Here I'm adding to L0, but this M should be, this loop shouldn't be running. Here M1 should be 0. So everything should be okay. Maybe M1 is not 0? Oh, that's strange. It's outputting non-zero numbers. Yeah, this should M1 should be 0 because this should be just, and this should not be running. And if this is not running, yeah, so where does M1 get these values? I think that's the bug. M1 is initialized to 0, so it shouldn't, and this part should not be running. Yeah, very strange. Where is M1 getting non-zero values? Mm-hmm. Yeah, something is happening here because MI, which should not be touched here, or is this loop? Maybe this loop is looping. Okay, if everything is working, this should not print anything. Okay, so and this should not print anything. Okay, so this is strange. There's some values being written to M1 when I'm not doing anything to M1. It's all zeros here. But it's not all zeros after this one. So that's... Yeah, so the 1 appears somehow in the... where it should be impossible for 1 to appear. So there's something happening here. But I'm not entirely sure what the problem is. Yeah, very, very interesting. Someone is writing to MI when no one should be, and it's inputting a number 1 into it somehow. It's probably some index overflowing somewhere, but I can't see where it would overflow. Okay, so basically if I don't do this thing here, the answers should be matching, but I haven't found the bug. Oh no, they're not matching again. What happened? M2L, if I commented out this whole thing, then it was matching. Let's confirm this much. Yeah. So this one reduces to the original step 11. Somehow adding this thing doesn't, which shouldn't do anything to the values, is doing something which breaks it. So I don't know what that might be. But so what if I just do this thing here? Will it still break? Yeah, okay. So something is broken and I don't know what it is. And so how can I find... So it's doing what step 11 can do, but it's no better than step 11 because the part that I added is not working. I think this one is okay, but maybe there's something wrong with this one here. Okay, I'll try to debug for 5 more minutes, and if I can't debug, I will just fix and upload the code later. Because I've explained to you how it should be working, it's just a bug. So once I debug, it should give you what it should. Oh, I know what's wrong. I'm specifying here p equals 1, so I shouldn't be able to print m1. The array size should be 1. So this value does not exist. That's one thing. But the other, so that doesn't solve my problem because this, maybe it does solve my problem. So I shouldn't be doing this when p equals 1. There's no such value as m1. Okay, is there anything else that I shouldn't be doing? Yeah, like this one I shouldn't be doing if p is less than 1. Or p is equal to 1. So this one, and these loops won't run anyway, so I don't think I need to do anything here. But I don't think this will solve all the problems, so that's another issue. Oh good, they are matching. Okay, so let's see what happens when we do P2. So these two numbers should match more if we include this higher order term. Okay, if they okay, so something is still broken because the answer is getting worse when I do P equals 2. Okay, I don't know what's wrong. There seems to be some difference, and so let's say I do very high order. The answers should match exactly, but it's probably going to diverge or something. Yeah, close, but not matching. Yeah, there's something that happened between using complex numbers in C++ and translating that to C. So that's, maybe I should have just coded in C++, just for the sake of avoiding this error. Okay, so it's sort of working, and it's giving roughly the correct answer, except going to high order is not giving you more accuracy at the moment. So there's something wrong with the kernels, and I do not know what it is, but it's a good start for, for what the fast multiple method should actually look like. So it will look like this, except, without bugs. So you can start from step 12, which I will fix and upload, and then you can use it as a starting point for any kind of development. So I'll upload step 12 when it's debugged, but for now I'm not going to upload until it's debugged. So just to avoid confusion, I'll delete the step 12 that's here because it's confusing to have it here. Okay, so if you see a step 12 in this folder, that will mean it's debugged. So that will tell you if it's debugged or not. And yeah, I think so. Basically, we have in the hands-on, we have from step 1 to step 12, gradually introduced the different stages of fast multiple methods. So by the time we get to step 12, we have introduced all the necessary components. And so now, you can just use step 1 through step 12. If you want to develop some more features, you can always go to start from the easy one because you can most of the time do different tests with the simpler cases and just use this one to check if the overall answer is correct in the end. So yeah, so please use these codes as some test case if you want to do more development. Like parallel, you can do the OpenMP and AVX stuff for the other steps. Maybe if you want to do something on GPU or do MPI, you can start from the easier steps and not necessarily do this one. And also you can use the kernels in step 12, change it to your own equation that you want to calculate, and without changing the outer structure, because up to step 11 we know that it's working, so there's nothing wrong with the outer structure. It's just, there's something inside the kernel that's not working for step 12. But if you change that to something you want to, and if those are working, then it's easy to check for step 12. Okay, so thank you for participating in the last hands-on. And if you have any questions, you can email me at, let's see. Yeah, I'll put it in my last slide. So here, I'll upload also all this new today's slides, but I just want to, in case you have any questions. Okay. You can email me at this address, and I'll upload this slide so you don't have to write this down or anything. Just so any questions, I am available. I won't be here anymore, but I'm here for another 2 days, so you can email me, and once I go back, you can still email me, and I will still respond. Okay, so any questions, you can ask me at this email address. Okay, thank you. Yeah, the last one didn't work, but I think everything else worked, so I think it's good. Okay.
How about we take a group photo?
Group photo, okay.